Phasing. Phasing is one of the things that we struggle most as a company, installers and service techs across the board. Surprise, you do have to have the system phased correctly. If you don't have it phased correctly, the measurements are going to be completely off. For the Neurio and the Tesla remote meter, it's more important because the Neurio and Tesla remote meter are powered by a different breaker. So when you have the Enphase combiner or you have the Solaredge combiner, the CTs in those are powered off of the feeders that are feeding that combiner or the Envoy. So whenever you're connecting the CTs from the combiner or Solaredge, it's being powered by those phases. It's reading off of those phases. Now for the Neurio and the Tesla remote meter, those breakers can land anywhere on this panel. And if it's phased differently than everything else, then your readings are going to be totally off. So the Neurio and the Tesla remote meter are a little bit more tricky because you need to make sure everything's phased correctly, because you can have the Neurio and the Tesla inverter on a different phase than in the MSP, because the inverter, the Neurio and the inverter is reading off the lines that are going into the inverter, and then you can have the breaker on completely different slots, and they're reading a completely different phase. So that's why Tesla is one of the most complicated. So typically on most main service panels, line 1 is going to be the left feeder, line 2 is going to be the right feeder. If you didn't know it or not, the lines from the utility are the same. It's just a universal designation that line 1 is on the left and line 2 is on the right. These are both 240, like the lines running in is 120 volts, 120 volts, and that's how you get 240. So when you get the two pole breaker, that's the 240. There's not a difference in the lines in the utility. They're both 120. They vary a little bit in their voltage, which is why they need to be phased. They're not going to be the same voltage going across the board all the time. But universal designation, if you have the main breaker up here, left one is going to be line 1, L1, the black wire. Right feeder is going to be line 2, red wire. Okay. So when we're phasing, the most important thing, especially for Tesla, is making sure that the breaker for the Neurio or the Tesla remote meter is phased with the main breaker. So to do that, you're going to grab your 2-pole breaker, and what you're going to do is you're going to put one lead on line 1, and then you're going to put the other lead on line 1 of the main breaker. And if it's zeroed out, you're going to get 0 volt rating on your voltmeter. That's how you know that you're on the right phase. For line 1, make sure that if it's the Neurio or the Tesla remote meter, you're using port 1. That's always going to be line 1. On the Neurio remote, it's going to be also port 4. Port 4 on the Tesla remote meter does not work. So don't try it. If you try and use it and it doesn't work, that's why, because there's no compatibility. It doesn't work. Port 4 is non-existent on the Tesla remote meter. So make sure that you're phasing. Just to be safe, check line 2 and make sure it zeroes out. Like maybe you had a bad connection or you put the lead on the wrong pole and you didn't realize it. But make sure that you check line 2, even though you check line 1, to make sure that it's phased right. Now, the other important thing for service panels, every single service panel is different. Some service panels, they only have single poles at the top, right? Meaning if you try and use 2 single pole 15 amps up at the top, you're going to land on the same phase for both of those phases if you try and power the Neurio off of that. Some panels, only 2-pole breakers are at the bottom. So just make sure that you're keeping track of it. That's another reason why it's important to test both of the poles on each breaker, is because every single panel is different. And you could have one section of a panel where it's all one stab, all one phase, and then you have to move to a different section to grab both phases, okay? If you guys don't know, a lot of the main service panels that you're coming across, I mean, most of them in Arizona are pretty burnt out from the sun, but there is a panel schedule on a lot of the panels, and it's going to tell you the schedule of the breakers so that you know which phase is landing on which breaker slot. So that'll also be a good indicator for where you can grab particular breakers to power the Neurio or the Tesla remote meter. Now, After you're done phasing the Neurio or the Tesla remote meter, make sure you phase the PV breaker, especially for Tesla and Solaredge, or especially for Tesla. Because again, if your Neurio breaker is phased differently than your PV breaker for Tesla, then you're going to have the inverter on a completely different phase than what the Neurio is tracking. So once you confirm, the Neurio breaker should be the source of truth. And your Neurio or the Tesla remote meter should be your source of truth for phasing. Once you figure out the phasing for that breaker, then phase your PV breaker and make sure that PV breaker's phased. And then you're just going to keep on working down the line, further and further, till you confirm that everything within the whole system is phased correctly. All the black L1 wires are landing on the correct phase, and then same with red. One of the big issues that I've also seen is with jobs with more than one Tesla inverter. And you can even apply this to Enphase, or you can apply it to Solaredge. When you're combining multiple inverters into a combiner panel, they're not phasing them. You got to make sure they're phased. Okay, so when you're coming across a combiner panel like this, say these are your two solar breakers, make sure both of these are phased to the feeders that are powering it. Because if they're not, then you're going to have one inverter reading off of one phase, and you're going to have the other inverter reading off a completely different phase. A lot of the installers are just slapping breakers on. They're putting the L1 at the top, red at the bottom, and they're just doing it across, and they're not realizing that the stabs rotate from side to side. So again, if you're coming across a job with multiple inverters and you're combining them in a combiner panel, make sure that you're phasing this panel out with the feeders that are feeding it, so that you confirm that both inverters are on the same phase. Because again, just remember, especially for Tesla, if you have two inverters in here and they're on different phases, each of those Tesla inverters have a Neurio that's being powered by the feeders that are feeding it. So you'll have two different Neurios on two different phases, and then when you throw in like a standalone Neurio and MSP, then you can have a third Neurio, and then you're trying to figure out which one that one's matching up with. So phasing is extremely important. Moving to backup gateway, phase this out as well. What's the biggest thing that you guys need to remember for the breakers in the gateway? Breaker flips it. So with an Eden breaker, so this one's lug fed, just pretend there's an Eden breaker. Which line is this one supposed to be? Red. Yeah, it's going to be L2. So whenever you come with the Eden breaker, make sure whoever battery tech wired it up or installer wired it up, if it's an Eden breaker, make sure this is L2 and then this is L1, so it flips. I've seen several jobs now where they forget that it flips, and then they have the power wall breaker landed on here, and the power wall's phase different than the power that's feeding the gateway. And it's creating some really, really rough readings. So make sure if you're doing an Eden breaker, just remember that the phases flop, and you need to have red wire L2 right here, and then black wire right here for the Eden breaker. But do the same whenever you come across a gateway, phase L1 and L2 with your Tesla Powerwall breaker. Make sure that they're on the same phase. If you're powering the Tesla remote breaker on here, phase that with these feeders. Because if you already phased everything in the MSP and you're working your way down, then you're getting to the gateway. Make sure, again, you're phasing the gateway with the Tesla remote meter and with the Tesla Powerwall breaker. You want everything to be on the same phase. Now, some of the situations you're going to be coming across because of LightReach in Arizona is LightReach does not allow existing systems to land within the backup circuit. So you can't land an existing system. If you see a LightReach job and no one's caught it, then you guys are going to be the last line of defense. If you see a LightReach job and they have the existing PV system landing in the gateway, that's a no-go. It can't land in the gateway. It can't land in the backup load panel. What CAD is usually doing is they're doing either a supply side tap on these feeders right here, or they're doing a load side tap. So make sure, again, if there's an existing system present, it's not landing on the internal panel board in the backup gateway or in the backup load panel. If the existing system is being a supply side tap or a load side tap, you can't use these CTs anymore in here. for Tesla, Tesla needs whole home monitoring, including existing systems. So if there's a supply side tap or a load side tap right here, you need to use the Tesla remote meter and put a pair of site CTs upstream of that tap point, okay? Because you need to be able to track the whole site. Say for instance, you put the existing system right here. Tesla requires that existing system to be monitored, right? So you're putting one CT on here, marking it as one CT times 2. And if you don't have site CTs downstream, then it's going to throw all of your numbers off, because the site CTs need to capture all of the solar. If it's not, then it won't be able to pick up the solar. But since we have a CT on it, the app is going to be populating that power that's being generated, and it's going to throw all the numbers off. So whatever site CTs that you have on site, site CTs need to track all of the power that's on the house. So if you have any loads, if you have any existing system, you need site CTs upstream of those loads or that existing system. Okay, now if you have the backup switch, obviously the backup switch has your own internal CTs, so you don't need to worry about that. That's the last line, you don't have to worry. And then you just need to make sure that if it has an existing system, you're putting the CTs around that existing system. And again, we only need one CT, programmed as one CT times 2, and then we're golden, okay? The short answer is no, you can't. But the complicated answer is we have an agreement with LightReach that for systems that we designed a really long time ago, so towards the end of last year, that they're going to allow us to push them through, and we'll get an exception for them. So if the CAD was designed after January-ish, it's going to be a no-go. If it's designed before January of 2025, LightReach is going to allow us to push that through. Yeah, so make sure everything is phased out. In my opinion, over phase. Like just double check, triple check everything. Make sure the whole job is phased correctly. When you're doing the Nurio, make sure that that antenna is installed all the time outside of the MSP. Obviously, you can't for flush mount panels or interior panels. We'll get an exception for that. But if it's an exterior panel and you can put that antenna through the main service panel, please put it through, because we'll need a return trip. If there's any type of meter comms, LightReach will send us right on back. So same goes for the Tesla remote meter. Make sure that you install that antenna. If it's within like 10 feet, install that antenna. If the Tesla remote meter is probably like 20 feet away from that power wall, just hardwire that bad boy. Then you're not going to have a return trip because there's meter comms alerts. There's not going to be a second or third. If it's more than 20 feet, please hardwire it. You can hardwire it up to 150 feet. So there's a lot of leeway for hardwiring the Tesla remote meter. So please do it, and it'll prevent a return trip. Now, after you phased everything out, Tesla does give a pretty good indicator on their app of if everything's working. So the first thing that you can do to confirm that everything's phased, you have the CTs landed where they're supposed to, is turn the PV system off and look at your consumption. See what your consumption rating is for your CTs. Make sure that it's positive. And then whenever you turn that system back on, make sure that your consumption doesn't change. If it changes, you know that you're going to have some type of CT error. You can also check when the system's off after your CTs are installed. You can go into the app and you can see if there's negative values on those CTs. If there's negative values coming from those site CTs, you know that it's most likely going to be a phasing issue because you put them in the right orientation, right? If the orientation is right and you're still getting negative loads, it's most likely a phasing issue. Check on the app because that app can answer a lot of your questions, and it's going to let you know if the CTs are wired wrong. You can also check the production while it's producing. You can do just some simple math to make sure that everything's lining up, that the correct amount is exporting, the correct amount is consuming, and then you got the total PV. So you can just do some simple math, subtract the amount of power that's being produced minus the load, and then that should be the amount that you're exporting. And if everything's showing right, that's another good indicator that you got the CTs installed correctly. And whenever you go to RTR, there shouldn't be any issues. So when you're turning or activating a system, We are going to want you guys to stay on site for at least like 15 minutes while we can get data for monitoring. That way we can ensure that the CTs are installed correctly and that you guys don't need to go back after you've already turned on the system. If you guys want to do your due diligence and you want to check the phasing before you even turn the system on, you can do that. Just verify that the CTs are installed correctly, because RTR is going to look at monitoring when you're PTOing the system to make sure that it's looking good. So if you want to phase before you turn it on, that way you don't have to change anything, then go ahead and do that. But when you guys are PTOing and activating the system, RTR is going to be looking at the monitoring and just confirming that you guys don't need to go out there and fix something. Okay. One surefire exception for Tesla, there's two actually. Tesla and ConnectDR, auto CT exemption. If you have a Tesla system with a ConnectDR, don't even install CTs. If you come across a job and they're already installed, please remove them so that we don't have to go back out on site and remove them. The other exemption is Tesla PV only with an existing system present. That's going to be another auto exemption. So Tesla has two auto CT exemptions. It's going to be with the ConnectDR and it's going to be with an existing system. If you see either of those situations and CTs were installed, remove them. RTR will pass you, and then we'll get a CT exception. If it's any of those other scenarios, we got a bundle. I know you guys hate bundling. I would hate bundling if I was in the field. But if feeders aren't accessible and it's not meeting any of those two conditions, make sure you bundle. Now, I know there's going to be panels where you can't fit CTs, right? Especially in those single row bus bar main service panels that are like 100, 125. They're like super slim, especially if they're packed really tight. We can get some exceptions, but I have to ask you a favor. You guys got to make it look really bad. Now, what I'm saying is install like 3 pairs of CTs, make it look as tight as you humanly possibly can. Have those CTs sticking out so that, you know, the clasps are like facing out. You want to make it look as bad as you can. Take a picture of the dead front not being able to close. Basically, we want to prove to LightReach we can't fit CTs in here. Now, you're not going to be able to do it if it's like half full. LightReach is going to say, BS, you guys can fit CTs in here if it's half full. But on those single row bus bar panels, the 100 amp, 125 amp, if they're full, there's a very high chance we can get CT exceptions. But you guys need to be creative and put CTs on there. Put 3 pairs at least 3 pairs. You can probably even put 4 pairs of CTs on there because we're going to need a lot of pairs for bundling. You don't need the CTs connected to the Nurio. I don't care if they're plugged in, but you need to show the CTs bundled and show that it's terrible and that the dead front's not going to fit with them bundled, okay? But we do need to provide pictures, so make sure you take a ton of pictures showing how terrible it is, showing the dead front can't close, and then I'll get a CT exemption for that. But otherwise, especially if it's a full-on panel, we're going to need a bundle. LightReach will require us to bundle. Nurios have Y splitters that you can use. So you can use a Y splitter on every single port. When you're using the Y splitters, you can use 4 pairs of CTs. If you really have to, we could probably get an exception. If you have to add another Nurio remote or another Nurio meter to add more CTs, I think we can get an exception for that. So if 4 pairs of CTs aren't working, then we'll figure it out. You can't double up on Y splitters on the same port. It's limited to 1 Y splitter per port, okay? So don't double it up. Tesla remote meter does not have Y splitters, okay? So that's where a Tesla remote meter kind of sucks. They don't have Y splitters, so you're just stuck with what you have. So we'll be creative, and that'll be kind of like a case-by-case situation where we'll figure out what we need to do. The unfortunate part is for Powerwall 3s, they do require whole home monitoring. So LightReach will require us to be creative when it comes to the Tesla remote meters. Now for the Powerwall 3, we can install 2 remote meters max, 1 wireless and 1 hardwired. Powerwall 3, I don't know why Tesla allows this, but they allow you to wirelessly program 2 Tesla remote meters. I don't know why. It's the stupidest thing ever. I've seen several jobs where techs have installed 2 Tesla remote meters and programmed them both wireless. Only one can be wireless. Only one's going to work. So if you have 2 TRMs on site, one needs to be wireless and one needs to be hardwired, okay? So Solaredge panels. This isn't a Solaredge panel, but let's pretend that this is a Solaredge panel. So if you have the Solaredge panel, you have the Solaredge slot up here. If we're landing a PV breaker right up here in the Solaredge slot, we need to have site CTs around these feeders right here, because these site CTs need to be tracking the power that's being generated from the PV. Now what you need to do is you're going to have a standalone Nurio in here, and you're going to use Y splitters. So you're going to use Y splitters, and you're going to put a pair of CTs on the main feeders, and you're going to put a pair of CTs on the Solaredge slot. That's how we're getting success, okay? So make sure you're doing that. Make sure you're using Y splitters on the Solaredge panels. You're just gonna, again, make sure you phase it right, okay? You need to phase the Solaredge slot, phase the main breaker, and then once you phase everything, use Y splitters, and then put 4 CTs in this panel so that you're tracking all the site. Yeah, source needs to be facing the utility on the Solaredge slot, yeah. It seems to be a better interface. It seems to communicate a little bit better. I think it was Josue that was on site, and we weren't using Y splitters, and it was giving us really wonky readings. Once we used Y splitters, I think the CTs were able to communicate or track all the electrical current a little bit better when we use the Y splitters versus having standalone CTs on their own ports. So if you can, use Y splitters. If you're not using Y splitters, then make sure you're looking in that set app to make sure that your numbers are correct. Now, other thing that I want to mention that I forgot earlier, when we're load bundling, so say it's Tesla PV only, we're load bundling because LightReach sucks. The new PV breaker for Tesla needs to have its own CTs on it that are set as site. Okay? So it needs to be set as site because we're not installing site CTs on the feeders, right? Because they're inaccessible. We need to install site CTs on the PV breaker, but they can't be bundled with any other loads. The CTs track electrical current flowing. So if you have the PV breaker bundled with other home loads, you have two currents going opposite directions, and it's pissing the CT off. Because if you think about it, the CTs that are on these feeders, they're only tracking electrical flow one way or the other. They're not tracking two different flows at the same time. So when we're bundling loads for our new Tesla inverter, you need to put site CTs on that PV breaker with no other loads going through that. And then the rest of the home loads will be bundled like they normally are. So now, Solaredge and Enphase. Solaredge and Enphase, since we don't have a Nurio breaker, you're going to want to phase it off of the PV breaker. And just to be safe, I would phase it off of the wires inside the combiner or inside the Solaredge. That's going to be a surefire way to make sure that you know that everything's phased correctly. Now, one of the things that I recommend, I've already talked to Brad. He's getting all the color-coded wires. I know there's some people in here that like the white and blue wires, but he's getting rid of all the white and blue CTs, and then he's moving them to the blue or the purple and brown, and then the black and red. So there won't be any more white and blue CTs for Enphase. It's all going to be color-coded to the new combiners. So make sure when you guys are bundling loads, make sure you're tracking those colors. I've seen a lot of jobs where, especially in the white and blue ones, they're getting everything mixed up for the different lines because they're not taping the wires either black or red. So one of the things that I would do, if you're using the white and blue CTs, tape your ends blue or red or blue or black, depending on what phase you're on, so that when you're running it to the Envoy, you know which ports they need to land in the Envoy. Okay. Now for Enphase, LightReach is going to require us to capture the existing system that's on site. So we need to put a set of CTs on the existing system with the arrows facing towards the PV breaker, okay? It's not going to be towards the inverter. It's going to be arrows facing towards the PV breaker. Now, when we're doing that, make sure that those wires are matching up. That's the biggest mistake that I'm seeing in the field is that the wires from the CTs are not matching up when they're splicing in site CTs from either an existing system or from bundled CTs. Make sure those lines are matching up so that whenever you're landing it, it's on the right phase. Now, the second thing with Enphase, it's not as user-friendly for immediate visual except for their live status. You have to wait like 15 or 30 minutes for any data to populate on the graph, but you can still see on that live monitoring portal, you can see the live numbers while you're doing the Enphase. But I highly recommend tape your wires for your Enphase CTs, especially when you're load bundling or when you're doing an existing system. So just do your best to route wires correctly. Make sure you label them. Don't get mixed up, and then make sure your wires are landing correctly on the Enphase combiner. Otherwise, it's going to give you all kinds of readings. Especially if an installer was out there, they mixed up the wires. So just make sure all the wires are ran correctly and they're organized. Now, Solaredge. Solaredge is the same situation. Solaredge doesn't have different colors for their CT wires. It's just black and white. I don't know why they did it like that, but when you run in Solaredge CTs, I highly recommend tape the wires so you know which phase it's going to so that you're landing them in the Modbus correctly. Now, Solaredge, you can see the negative readings on the app. So once you install the Solaredge consumption CTs, you can go in, turn the system off. You can look on your app and it's going to either show export or import. With the system off and with any existing system off, it should be reading import. If it's showing export, then you know that the CTs are wired wrong and you need to fix them. Okay. Phasing for Solaredge is going to be the same as Enphase. So you'll just phase off of the inverter, you'll phase off the PV breaker. Now, with Solaredge, just like with Enphase, we need to monitor that existing system. LightReach is going to require it. So that's when we add the Modbus. Okay. I'm going to be getting a video of the Modbus today, a Modbus installation. But there's two different Modbuses that we have. And have any of you guys done a Modbus yet? I guarantee you will, okay? You are going to do a Modbus. Now, the thing with the Modbuses, we have two different Modbuses. One's going to have a red sticker on the box. That one's going to be Solaredge brand. There's going to be another one that doesn't have a red sticker, and that's going to be a Wattnode brand. That's going to be very important because it's going to be how you program the Modbus into the commissioning app for Solaredge. When you're adding the Modbus, you're going to go to the RS45 2. You're going to add the Modbus. For the red one, you're going to click and add Solaredge. For the non-red one, you're going to add Wattnode. So there will be step-by-step instructions for you guys wiring the Modbus, but that's the biggest thing. That's the biggest issue in the field right now. One of them gets wired as Wattnode. One of them gets wired as, or picked as Solaredge, even though all the labeling says Solaredge on all the boxes, okay? So make sure you're remembering that for the Modbus. For the Modbus, the RS485 wire on the Modbus is going to land on the RS485 port on your lead inverter. You're just going to double lug that puppy, okay? So whenever you're getting on site, you're going to figure out which inverter's lead on site if you have more than one. And that Modbus, you're just going to double lug the RS45. You're going to see that yellow cable. I don't know how familiar you guys are with Solaredge yet, since we haven't had a ton of Solaredge. But on the Modbus, it's going to be a little yellow cable with a yellow sheath around it. It's going to be at the very top of the Modbus. You're going to double lug that RS45 port into that port for the Modbus. That's how it's going to be wired up, okay? And then you'll just go through the setup steps. Now, just as a reminder, with Solaredge, with the white CTs, you need to program those CTs to 225 amps. That's what they're rated for. They're not rated for 200. So make sure you program them for 225. If you don't, then the readings are going to be off, okay? Especially once you get into more Solaredge, if you have to lengthen the wire on the Solaredge CTs, you need to add that distance into the app. So when you lengthen them, you're not going to do the wire length. You're going to do the conduit run length. You're going to measure the length of the conduit run, and then you're going to enter that into the app. So it could be 20 feet, it could be 50 feet. Just make sure if you're extending that wire, you need to change the length of the wire in the Solaredge app so that it's the same, okay? Now, one of the nice things with Solaredge is that we can use Rogowski coils. Rogowski coils ensure that you don't have to bundle loads, okay? So Rogowski coils are going to be your guys' gift. Now with Rogowski coils, what you can do is you can do a figure eight. So if you do a figure eight, there's nothing special. It's just a regular figure eight. Okay, figure eight. That'll capture all the site, so you don't have to bundle. Okay, it's a very beautiful gift. I'm sure that you guys would rather just do this in 1 minute than do all the load bundling on the main service panel. Okay, so if you're coming across an MSP and the feeders aren't accessible, grab a Rogowski coil from the warehouse and just do a simple figure eight. Now, if you have a situation where the feeders are so tight and you can't use a Rogowski coil, then you can use this and bundle all of line 1 together on the main service panel. You don't have like a ton of small CTs, so you just put this around, put all your line 1 wires through that, grab another Rogowski coil, put all your other line 2 wires through that. That's a lot easier than using 6 CTs or 8 CTs, right? So if you're coming across a panel where the feeders either aren't accessible or they are accessible and you can do the figure eight, grab a Rogowski coil from the warehouse and install this on site. This will make your life a lot easier and decrease the amount of time that you're on site, okay? So it'll wire, so a lot of these will come with a conditioning unit. So there will be instructions for wiring. 2 of the wires will go into the conditioning unit, and then 2 wires will go into the Modbus in port 1. And then there will be a conditioning unit that has a power source that will power the CT itself. So all the Rogowski coils do require a 2-pole breaker. They don't get powered by the Modbus at all. So if you grab a Rogowski coil, you need to have a 2-pole breaker, 15 amp or 20 amp, that gets powered, that this gets powered by. So don't forget to grab that, because you will need a 2-pole breaker and you'll need the conditioning unit for it. Okay? Make sure you grab it. Look at your MSP. Like if you're at a Solaredge job and it says to install consumption CTs, pull up a picture of that panel and see if the feeders are accessible, okay? If you're not using Rogowski coils, you can use up to 3 sets of consumption CTs with Solaredge. You can either splice them together or you can run them in parallel and double lug them into the Modbus. So if you need to use multiple pairs of site CTs for Solaredge, you can do 3 max, run them in parallel, or you can splice them together. Again, if you're splicing, if you're running them in parallel, keep track of the wire colors so that you're not jacking stuff up, because once you start jacking up the wire colors, then you're just gonna have to redo it because you're gonna have to track everything over again, okay? So, so that's what Solaredge. When you're programming batteries and PCS, Solaredge does have a CT tool that you will be required to go through, and it'll test the CTs for you. They are going to be rolling that out for all Solaredge installs in the near future, but that will be like a test app or a test helper, and it'll confirm that you have installed CTs correctly or not. So PCS is a bus bar control setting within the app. So you're probably most familiar with it on Tesla Powerwalls. But for the PCS, whenever you're programming it to, like, the standard is right around 160 amps is probably what you're used to programming it. When you set it to 160 amps, the site CTs and the solar are being measured at the same time, and it's going to allow you to backfeed as much PV as the system wants, until you have a combination of utility power and solar power reaches 160 amps. And then once it does, then it starts throttling the inverter and lowers the production so that at any given time, the combined power from the utility and from the inverter isn't exceeding 160 amps. That's actually really cool. On previous versions of PCS, I don't know how familiar you were with like Enphase and all that. It was like PCS, but all they would do is they would take like an 80 amp backfeed system and then they would limit it to 40 amps of backfeed, and it's not super beneficial to the homeowner. With this PCS and bus bar control, you can feed as much solar as you want, and then it'll just start throttling the inverter once you hit that PCS limit. So one of the things that you'll see on Tesla, you have to subtract an existing system or a second inverter on that PCS. So just hypothetical situation, you have a job with 2 brand new Tesla inverters. We're using PCS. Standard practice would be to set that PCS to 160 amps. But since there's a second inverter on site that's uncontrollable, you need to deduct the backfeed from that existing system from the PCS. So if you had 2 7.6 Teslas on site with the 40 amp breaker each, right? You'd have your 160 amp PCS setting, and then you need to subtract the 40 amps from that second inverter from the PCS amount. So you'd be inputting 120 amps for the PCS setting for that Tesla. Solaredge also has PCS, but they don't have you do any of those crazy steps. You basically toggle in the commissioning app. This has an existing system, and then you put in whatever the breaker size is for the backfeed and Solaredge, and then it does everything for you. You don't need to subtract anything like Tesla makes you. So you guys probably know a lot of the tech help is helpful maybe 50% of the time. So if we are using PCS, we most likely need it because they do have PCS on solar only, which is allowing us to not have to do MPUs or D rates or anything like that. So there was a Tesla tech the other day that said that Nurios weren't meant to be standalone in the main service panel. And it's like, what are you talking about? So I would take about anything that a tech tells you, I would take with a grain of salt. Maybe 50% right, 50% wrong. You don't know. It just depends on the day and who you talk to. Any other questions? All right, perfect. If you have CT questions on site, please call Alex. Again, there's no such thing as a stupid question. Alex isn't going to judge you. I'm not going to judge you. If you're like, man, I don't want to look like an idiot in front of Josh or Alex, please give me a call. I'm not going to think that you're an idiot. It's better to be safe than sorry. It's better for you to ask a question and eliminate your pride and like thinking that you could be wrong or look stupid and avoid a return trip. And you guys ask that question and we get it solved first time while you're on site and we don't need a return trip, okay? All right, perfect. I appreciate you guys.